Hello, hello. I think I should be live. Might take a minute here to populate out to the feeds. I want to say hello if anyone's already watching. And if anyone already is here watching, say hello in the chat. Whether you're watching on YouTube or we're also streaming on LinkedIn. I'm going to say hello in the chat here. And also maybe put in where you're watching from. It's always kind of fun to see as well, where people are tuning in from. And if you want to provide a little bit more details about maybe why you're interested in learning about ML pipelines, which is what we're going to cover today. This is Intro to ML Pipelines workshop. And we're going to wait a couple minutes. I know we're already a minute early right now as well, but we're going to wait a couple minutes for people to tune in. So I'll wait till I see a little bit more people roll in here. But again, as people are rolling in, say hello in the chat. Maybe put in where you're watching from. And if you want to share any more details about why you're interested in building ML pipelines, if you have a project in the works right now, maybe it's actually for work, something in production, or maybe you're just learning and have a hobby type project, share that as well in the chat. And let me just make sure that we are streaming. If anyone also wants to put in the chat that you can hear me, see the screen, it's always good for me to double check as well. And again, we'll get going here shortly. Also, if you're tuning in a little bit later or watching the recording, all the links to everything to follow along are in the description. So if I will share them kind of as we go in the chat to follow along, but they're also down in the description. So if you don't want to wait for the chat links or you're watching this as a recording, check out the description. First thing, if you're joining and you want to follow along, which I hope a lot of you do, you might not have a Union account. It's going to be the platform that we're going to be running workflows in today. It's free to sign up. There's no card required. It might take 3 to 5 minutes for your sign up to be approved. And if that doesn't go through, let me know. I know there's some checks in place to make sure that the accounts don't look suspicious at all. So if you don't get a sign up in like 5 minutes or on board in 5 minutes, let me know. You can let me know your GitHub username in the chat, or you can also join the Slack channel and post it there. And then to follow along, again, like I hope a lot of you want to follow along, we have a notebook here. And again, I'll share these links and go through opening them up when we get to it. But if you want to start poking around as I'm talking, you're more than welcome to. I know I like to do that when joining workshops. Once you go to this GitHub repo, I would just hit open in Colab, and that's going to take you to an environment that we're going to run all of our code in today. Again, I'll go over this again when we get to it. And then also, if you have questions later, ask them in the Slack channel here. There's a lot of people around Union and the Flyte community, which if you don't know what those are, don't worry, we'll talk about them here shortly. But if you have any questions outside of kind of during this live workshop, let me know or let us know in Slack later. There's like over 4,000 people in there. It's a pretty strong MLOps community, so it's a great place to ask general questions, but also about Flyte or Union. We're in there as well. Awesome. Again, cool. I see a big bump of people joining, so we're going to get going here shortly. If you're just joining, all the links are in the description below to follow along, but I will share them again when we get to the hands-on coding part. And we're going to go through some slides first, just to kind of get everyone on the same stage, talk a little bit about workflows and pipelines, and then we'll do hands-on coding. So stick around if you want to go and build a pipeline today. I think it's going to be pretty exciting. If you've never built a kind of MLOps pipeline or a machine learning pipeline, this could be your first time. And again, don't worry if you don't have a lot of experience with machine learning or Python. You'll be able to run all the code today, and I'll explain what's going on. And if you have any questions, just let me know in the chat. And it's okay if this feels like, oh, a little fast-paced or maybe challenging depending on your level of familiarity with machine learning. But again, don't worry. I'll kind of go through and explain everything. So even if you've never trained a machine learning model before, we'll actually do that today as well. We're going to build a pipeline today that actually looks like this. So it's going to download a data set, process that data, train the model, we'll evaluate the model. We'll then use that model to run another prediction. And then we're also going to look at how we could upload this model or move it to another platform. In this case, today, we're going to move that model to a platform called Hugging Face. Again, don't worry, I'll describe all these things. when we get to the hands-on part, but we're going to build a workflow that looks like this. Download data, just all the things I said, but this is kind of the flow of the data and what the platform looks like. Again, we'll go through how to build this, and we'll be running everything in the Python SDK today. So again, links are in the description. Since I saw so many people join, again, I'll share the link in the chat again. This is the main one that you should sign up to now that can take a few minutes for you to get onboarded. So go ahead and do that. Again, there's no card required. I think you get $30 of compute credits. So we'll be using just a tiny, tiny fraction of that today for our machine learning use case. A tiny bit about me. My name is Sage Elliott. I work at Union. We build a platform around building ML pipelines, and you're going to see that in action today. A lot of people know us for our open source platform called Flyte, which I'll also briefly talk about, and I'll share a GitHub link to that later. And what you see today, you'll be able to implement on the open source as well. And then I live in Seattle. Is anyone else watching from Seattle? So it's kind of fun to see where people are tuning in. So again, see a big chunk of people tuning in. Let me know in the chat where you're watching from, and maybe a little bit about why you're interested in building ML pipelines. I also run an AI book club where we read a new AI book every month. If you're interested in learning more about that, again, go to the Slack channel. And previously, I've done a lot of work in computer vision, ML monitoring, and evaluation. And also, I used to be a hardware engineer working a lot in IoT and smart lighting. And if you want to stay connected, I'm pretty active on LinkedIn. You can ask me questions there as well, but I recommend joining the Slack and asking questions there. A little bit about you. So it's another opportunity. Where are you watching from? What are you working on? Why you're interested in ML pipelines? Put something in the chat. I see quite a few people joined in. It makes it way more fun for me presenting, but I think also for other people here. Say hello in the chat and maybe a tiny bit about yourself. Again, bare minimum, just put in where you're watching from. And I see, again, big chunk of people joining in. So don't worry, you're right at the beginning. We're just going through some slides, and then we'll be going on some into the hands-on code part. Someone said they're also joining from Seattle. Awesome. Like I said, I'm streaming from Seattle, and you're a student at UW. Very cool. Again, anyone wants to put in the chat where they're watching from? It's kind of fun to see where people are tuning in from. So again, today, what we're going to build is a model workflow where we're going to create a container image. We're going to download a data set, process the data and visualize it, train a machine learning model, evaluate a machine learning model, save the machine learning model to Hugging Face, and then use the model for inference, both through an API, but also how we can use it locally. So we're going to do some concept overviews here in the slide. We're going to run everything out of a Colab notebook that ties to Union serverless. The setup is pretty simple. And then also today, we're going to maybe run a relatively simple workflow or a machine learning model. But everything you learn can tie into much more complex workflows. And in fact, if you're curious about looking at more complex workflows and model types, like on the same YouTube channel, if you're watching on YouTube, we have videos of doing this with like object detection workflows and fine-tuning large language models. So today we're going to use a scikit-learn model, but you can expand this out to kind of whatever models or libraries you're using. So just a kind of quick thing on MLOps, or maybe you've been hearing about LLMs and that you've been hearing the term ML MLOps. Really kind of a quick thing about an ML pipeline. Has anyone ever built a machine learning model and put it in production before? It's always kind of fun to hear about. So MLOps is the set of best practices and tools that aim to deploy, monitor, and maintain machine learning models in production. And then I really like to think about how to do this reliably and efficiently. So most of the time, this is kind of a bare minimum example of what a machine learning pipeline might look like. And again, it can be way more complex. It really depends on your use case. You can have way more steps in this, but at bare minimum, you're probably going to have these steps in some manner, which is going to be collecting data, training a model. So you need data usually to train your model. Then you're going to evaluate a model, make sure that it's going to perform, as well as you can before you put it into production. They're going to ship that model to production. Once it's out in production, usually do something called monitoring. There's really cool platforms and tools for this. But at a bare minimum, you should probably have some sort of practice or process of how to look at a model in production and see how it's performing, because once you put an ML model in production, that's usually not the end there. You're really kind of looping over this life cycle over and over. So you might hear this called like the ML lifecycle data flywheel, something like that, where you're collecting data from production, then monitoring when that data might shift. Something called data drift, where the data no longer matches what your model is trained on. Chances are your model is not going to be performing as well on that data anymore. So when I take that new variation of data, train a new model with it, evaluate it, ship, and put it in production. And again, there's way more steps in this, but at a bare minimum, you're probably going to be doing something like this. Has anyone ever put an ML model in production and had to monitor it, or have you seen anything kind of weird go on with it once you put it in production? And Robbie said, joining from New York, working on Gen AI apps. Awesome. What kind of Gen AI apps are you working on? Again, if you want to share more in the chat, it's always interesting to hear about specific projects. And someone said, former UW, listening from SF. Awesome. Thank you for joining. And again, thank you for putting in the chat. It makes it more fun, me actually seeing people are kind of watching. All right. So kind of how do we make all these things work? You've probably seen some of these libraries before. Again, there's so many cool things happening in the machine learning space right now, where there's a lot of great libraries that make it kind of easier to do all these steps that we talked about. You're not building everything from scratch usually. So here are some libraries you might have seen. If you've used any of these, again, put in the chat. Like there's a whole bunch for like validation, training, deployment, etc. But to make all these work together, you need to kind of unify them on often like a compute platform. How do you pass data between all these things? How do you make sure that they're all running very efficiently? And that's where like workflows come in. And today, again, we're going to be using the Union AI platform to build our workflows. But kind of just to go a little bit more into workflows, like which are kind of the core of ML pipelines or pipelines in general, really doesn't always have to be machine learning related. You'll see a lot of overlap in like data engineering. Again, I like to think of this as like, how do you create workflows that are reliable and efficient for your AI applications? So first, you have scalability, which facilitates the scaling of AI workflows to handle large data sets and complex models. Also, if you're serving, you might want scalability there as well, where if more users come in, you can spin up compute for that. Reproducibility, where you want to ensure that the workflows can consistently be reproduced, which also helps with like collaboration and transparency in your org. Versioning, a lot of you have probably used GitHub before. Think of kind of versioning your whole ML pipeline and how useful that could be, not only tracking the code, but all the data and maybe those artifacts from each step in the pipeline. Like how did the data transform over time? What did the data look like when it went into the model? And then you evaluated the model and then you put that model in production. How can you tie back and maybe find out issues that happened in production and tie that back to your data? Sometimes this is required. If you're in a more regulated field, like some healthcare and financial stuff, you really want to keep track of versions of everything so you can go back and track that. And then improved efficiency and cost efficiency. These are huge things that like everything here is kind of like often you're going to need it or want it in your pipeline. Implementing this, sometimes if you have to get buy-in from other people in the company, talking about improved efficiency and cost efficiency is a really good way to kind of get buy-in from other people in your companies to adopt new tools. So like you want to allow your data scientists or ML engineers to focus on the more critical aspects of development. Someone once said at a conference, I really like this phrase of like, my ML engineers shouldn't have to write a Jira ticket to get a model in production, which I thought was really fun. So you want to have like a way where you can collaborate and kind of ship things out, even if they're in like a shadow deployment mode, maybe not actually fully in production, but you want to allow people to experiment very quickly. And then cost efficiency. This is a huge one. If you've built any AI applications at scale, you know it can be pretty costly. So you want to be able to optimize your resource usage, which reduces the overall cost of developing AI models. And just to kind of hammer again on some of the cost stuff. So this is where when I help people kind of adopt more modern workflows, some things that really stand out to me of where they find a lot of savings is this one might sound obvious, but optimize for local and cloud development. Not every workflow tool allows you to kind of develop your workflows locally and test them before kicking off more large production cloud training jobs, for example. So you want to be able to utilize your local compute resources before kind of kicking out these jobs. So for an example, if I'm developing a workflow for the first time and I can't test locally, I have to test every time spinning up a container and waiting for a cloud job to run. That can take like 10 minutes sometimes just to get like an error code So I really want to get that error message as quickly as possible. And a lot of times you're going to have pretty powerful compute now. Like if you're running on M3 or M4 MacBooks now, you can do quite a bit locally before kicking off longer training jobs. Leveraging caching in a pipeline. So for an example, this little example pipeline here, we're going to get data, pre-process that data, and then train a model. Often, if you're experimenting and training a model, you're changing things like hyperparameters, but you don't need to download the data set or pre-process the data every time, because in this case, like that data didn't change. We just want to rerun the whole workflow, but we don't want to rerun this part because it didn't change. So you can just pass in like a hyperparameter change or something to the the model training, and you don't have to rerun this. This is already cached, so just in this case, it's just going to rerun that training task. Because like downloading data set, for example, could, like in this case today, won't be that huge of a job. But if you have a big data set with like images or point clouds or something, that can take quite a bit of time to download, and you wouldn't want to do that every time you're rerunning the workflow for like training, for example. Task level resource and management and containerization. So you'll see this today too. Every single task that we build in our pipeline. So for this example, we'll just go back to this. We have these 3 tasks. Let's say that this training model is the only one where we need a GPU on. We don't really want to waste the GPU resources on these other ones that could be taking a long time again. So for every single task we're going to build today, we're going to assign the exact compute that we want it to run on, as well as the container image. But the compute thing's a big factor here. Again, you might have built a workflow in the past where you're running everything on a single compute cluster and wasting a lot of potential GPU time, which again could be very costly. Or maybe you're kind of hogging that GPU resource from someone else in your company that could be using it. So we're going to see today how to do this for every single task, like run as efficiently as possible. And then actually we'll also see that we'll assign this compute, and then we can actually see how much it utilized of what we assigned. And then you could go back and tune it down. So often also, and I've been guilty of this, where I'll set like, I want this many CPUs and memory, and then I run the task and it works. That's great. And then I never look at it again. But then you can actually look at resource utilization and say, well, it uses like half of that. You don't have to be paying for all of that every time you run that task. And then so you can pull the resources down to what makes sense for your workflow. Also, mitigating errors of type safety. So Flyte and Union enforce type safety per task. So basically, when you define it, you're going to say the input is going to be a certain type and the output's going to expect to be a certain type. And it'll yell at you at compile time when you're trying to build that task if you didn't do that correctly. And then one thing to also shout out is the economic benefits of spot instances and batch processing. So I don't know if anyone's used spot instances before from like something like AWS, where they spin up compute and then instead of just spinning it down and not making any money on it, they will sell it at a pretty big discount. I think by sometimes up to like 90%, but it's not always available. And that can also save you a ton of time, or sorry, not time, a ton of money. Often will take more time. It's not as reliable. So if you're okay with waiting like, a few hours or something like that for a training job to happen, or for batch inference to happen, then you can check out doing this. Another good little thing to point out is like OpenAI recently came out with batch processing for their API, where it can save 50% of time, but it won't be real time. So again, you might have to wait a couple hours for it to process all those documents or something. And today, to build out our pipeline and ML model, we're going to be using Union, which is a unified AI platform where we orchestrate all that compute like we talked about in tasks, and then build out a workflow like we saw earlier. It is built on top of Flyte, which again, you can check this out here, which is the open source orchestration platform that kind of came out of Lyft. And most of what, if not all of what we're going to see today, you can actually do on the open source. So we're going to be using something called Union Serverless today because it makes it really easy to run the workshop, where you can just sign up and run workflows on it right away. You don't have to set up your own Kubernetes cluster or anything like that. And Union is going to have declarative infrastructure. Again, we'll see this in action, where we say the compute we want each task to run on. Has built-in versioning, so every time you run a workflow, that's all versioned. So you can go back again and see like kind of what happened. As caching, like we talked about, type safety, it's incredibly flexible. So most of your ML libraries or deep learning libraries in Python are probably already just going to go ahead and work in here. But there's also a pretty extensive plugin ecosystem. It has checkpointing. It's scalable. It's built on top of Kubernetes. So depending on your Kubernetes cluster. You'll be able to just kind of scale up to the compute that you need. And then it has a really nice user interface and API, Python API that we'll see in action today. And just to reiterate, every single task here is containerized. And if you haven't worked in that kind of environment before, we'll see this in action today. And just on the machine learning side, for this example, again, like I said, it's going to be a relatively simple example, but it can scale to more complex ML workflows that you want to build out. We're going to use a k-nearest neighbor machine learning model today from scikit-learn, which is a popular Python library. Again, don't worry if you've never even trained a model before, you'll be able to run all the code and train a model today and build a kind of state-of-the-art pipeline, which is cool. But basically, at a high level, how this works is you get a new data point, and it's going to map over a training data set, and then you get a new data point, and in this case, the k is equal to 4. So it's going to look at the 4 closest neighbors, basically, to this new data point, and make a prediction based on that. So here, 3 of them are pointed at versicolor, and 1 is pointed at virginica. It's going to say, this is more likely to belong to this class because more of the neighbors belong to that class. And then saving and versioning models, which we're going to do today as well. We're going to use Union. Everything's going to be versioned in there, but we're also going to show how to move a model out to something called Hugging Face Hub, which is a really popular area to store models and data sets. Again, we'll walk through this. So you also do want to set up a Hugging Face account. It should just take a couple seconds, actually, because you can just sign up even with a Google account or anything like that. And then with that, that's enough slides. Let's go ahead and get on to the hands-on part. So I'm going to share a link in the chat again. Everything's in the description as well. And you want to open up the GitHub link, and you'll get something like this. You want to open up this or click this Open in Colab link. And for anyone just joining, we're just getting the code part, so perfect timing. I'm going to share the direct Colab link in the chat as well, but clicking that button in the GitHub page should work. And then once you're here, I always recommend saving a copy in Drive. So this will give you your very own copy. And then if you want to save any like variable changes or anything like that, which we'll do a couple of, they'll stay the same. Otherwise, if you run this code, edit anything in the text cells, and then refresh it, it'll be gone, which is fine. And you can bookmark this and always come back to it, so don't worry about breaking it. But I recommend hitting save a copy in Drive. So that's what I'm going to do. And then again, if anyone in the chat wants to let me know, we're able to open this up. And are you ready to run some code? And if you haven't already, there's the sign up link for Union here, which will need. And then also Hugging Face, which you'll need in a few seconds as well, or in a minute. And I'll go through how to get an access token from Hugging Face. But if you want to follow along for the full thing, you want those 2 accounts. And actually, if you don't have the Hugging Face account, you'll be able to do run a lot of the workflow anyway, but it'll fail at the end when it tries to upload the model. And while people are opening this up, and I'll go through this again when we get to this part in the code cell, but just going to show once you have a Hugging Face account created like this, you want to go to your account, which I just like to get from this little icon up here. Go to settings. Actually, well, I usually go to settings. I guess you can go directly to access tokens here in the menu. We're going to go to access tokens. And then again, I'll go through this again when we get to it in the code cell, but you'll want to create a new access token. I think also when you create a Hugging Face account for the first time, if you did not verify your email, this button might be grayed out. So you'll need to verify your email too. And then you're going to hit create access token, give it any token name. You could say Union Workshop. I think it might need a dash between there. Union Workshop. And then the only thing you need is to click this write access to contents in the repo, and then just hit create token. And I'll go through this again when we get to it, but just want to quickly show it if anyone wants to go ahead and get there. And someone asked if I can share a link. So let me make sure. I think the thing is that you asked it from LinkedIn, and I think in the chat I posted it just went to YouTube. Give me a second, everyone, and I'm going to post some links to the LinkedIn live stream as everyone's opening up the notebook link. I will copy this and then just hit the Open in Colab button. And I'm posting this in the LinkedIn stream now. So Akil, you should be able to get these. And then you'll want to hit the sign up. And I'll also share a Hugging Face link as well. All right. And someone said they got it open and doing the Hugging Face link now. Okay. Is everyone ready? Everyone's ready to follow along? Well, I guess I'll ask about issues as we run code. Also, did everyone fill out the union sign up link? And again, if you don't get approved, let me know and I can try to get you approved from the sign up list. All right, so we're going to go ahead and run the code here. Again, I'm going to go to my copy of this. And first, we'll just run this first code cell. This is, Python for printing out some text. And you can run a code cell by hitting the play button. Or when it's highlighted, you can hit Shift Enter, which is often what I do. So if you don't see me hitting the play button, that's why. If you've never used Google Colab before, it's essentially Google's way of hosting a Jupyter notebook, but they give you a whole compute kind of instance behind it. And if a Jupyter notebook, if you've never used it, is a way to kind of put code, text, documentation, and visualize outputs all in one place. So it makes it great for running a workshop like this. Again, links are here to sign up everything if you need to. And then we're going to install some libraries. Colab, so go ahead and run this code cell. Colab also already comes pre-installed with quite a few of the popular machine learning libraries, but we're going to install some specific versions and a version of Union here and Hugging Face Hub. Again, we'll go through these libraries as we use them. And this is a good opportunity as well. While these are installing, it should just take a minute to sign up for the accounts that you might need. And also, while that's doing it, I'm going to get a drink of water. All right, so mine's already done. Shouldn't take too long. These are kind of lightweight libraries here. First, we want to authorize our Union account now with our Google Colab. So we're going to run this, and it's going to generate a link for us. And we're going to hit this URL. Don't change any of the letters here. Just hit next. And now it should authenticate here. And then again, just to kind of show what we'll be building is this workflow where we have this platform here. We're going to do tasks like download data. We're actually enabling caching here as well, like we talked about. We'll be able to process data and visualize that data directly in the task where we can embed things like charts and visualizations and anything we want about our data. And then we'll be training our model. Then we'll evaluate our model, upload it to Hugging Face, and also make a prediction here with the compute on Union. But before we do that, let's run a very, very basic workflow. This is almost the most basic workflow that you could probably run in Flyte or Union. But I want to show just kind of two of the core building blocks is we have a task and a workflow. And so a task is any of these blocks that you see here is a single task where we're going to kind of say what we want to happen and the data coming in and the data coming out. In fact, you could look at inputs here and we can see that processing data set is we're taking a certain file in and we're outputting two files, which is we're actually doing a train test split here. And then we have a workflow, which we is enabled by this decorator. So really, we're just writing Python functions, and then we're using the task decorator and a workflow decorator here. You also notice that we have type hinting here, which is actually enforced by Flyte and Union here. So if you didn't have this, it would kind of yell at you, hey, you need a type. Let me know what type of variable is coming in and what type I should return. And the workflow piece is kind of encapsulating all these tasks and telling us what the flow of data and how the order to run tasks in is. So again, we'll see this in action as we actually build out this more complex workflow. But just to show kind of the most basic workflow we can, we just have one task, and then we're just going to run that task inside of a workflow. So go ahead and run this code cell. And just to note, this is using something called write file inside Colab or inside Jupyter Notebooks. So we're using this, which is a function of a Jupyter Notebook. And it's going to take this Python code below and write it into a Python file called simpleworkflow.py. And if you wanted to, you could even open up this folder and see that this Python file now exists. And then what we're going to do is use this command union run simple workflow.py. And then we're going to say we want to run the main workflow, which is here. And it requires a name variable, which I'm just going to say Flyte right now. And we're going to hit run. Now, this is running it locally. Remember, we'd mentioned in some of the slides where you can develop locally, run a workflow on your local compute before kicking off into the cloud compute. It says hello Flyte. Now let's run this simple workflow into Union Remote. All we do is add this remote flag. And if we're authenticated, it's going to run this now on Union Compute. And we should get this URL here. Click on that. And then we can see that it's in progress here. You can go to this graph view as well, which I kind of like to look at, where you get the whole DAG. In our case now, it's very simple. So it's just has this task called hello world, and it's already done running. I can click on it. I can get some details around my execution here. Again, I can look at input, which was a string that just said Flyte. Output, which says hello Flyte. In our workflow here, all we're doing is taking in a string and adding it to the string hello. It's kind of a hello world example, but inside a workflow. And then you get some other details around task. And what's really cool is right from the UI, you can also do this from a Python API, which we'll see a little bit later. But right from this UI, we have this whole workflow registered. And again, it's pretty simple, but I can actually just relaunch it now. So I can hit relaunch from the UI here, pass in a new string, and I'll just say hello workshop attendees. And I'll hit relaunch. And now we have a new workflow version. You can actually see it's related to this original one. If I click on this, it'll take me back to the original one here. And cool, it's already done running. So now I can look at inputs, outputs. And this is, again, it's a very simple workflow here, but you can imagine that this could be pretty powerful for if you're doing things like testing different model types, different data sets, hyperparameters for models, that you can pass in strings or any other parameters. They don't have to be strings when you relaunch a workflow just directly from the UI. Instead of running everything with like changing parameters in code or anything like that, you can just do this very easily from the UI here. All right, so I see some questions coming in here on the chat, maybe some issues. Real quick, I'll just go over this next part. You can hit union run simple workflow main again and add in this help flag, which will tell you the name is required. And if you want to look at more useful things or other things you can do from running workflows, you can hit this little help tag, and I'll tell you a lot of more parameters you can pass in. Something to note in the UI, if you go to like this very home button, which is a union logo, you'll see a couple of folders here. I think you should just have Flyte snacks and systems. Everything today will be running a Flyte snacks by default. It's kind of the demo place, but you can hit new projects and create project folders. But I'll go into Flyte snacks, and I can see this is my execution that I just ran, and I can click back into it and get all that information again. All right, so let me catch up on chat here real quick. And next up, we'll be going through and building the full workflow. So again, sign up for a Hugging Face account if you haven't already as well. Let me catch up on chat real quick here. Someone said, running the union auth shows this error. Device not activated. Your device cannot be activated because of an internal error. Interesting. Doesn't sound good. Someone said getting a privacy error. Someone else said they're stuck at authentication. Let me double check something real quick and see what's going on. Otherwise, I'm not going to stop the whole workshop here, but let me just double check and see if there's anything I can do real quick in like a minute. And then we'll come back in and run this code below. And it should say, yeah, so the sign up page is on a wait list. Once you sign up there, you should get onboarded pretty quickly, like in a few minutes. And then if you don't get the onboarding email, you should also be able to go here and see if this dashboard is available, which is the serverless.union.ai. Give me a minute here, and then we'll come back and build this workflow. And if for some reason you're not onboarded for like this part of the workshop, which I do apologize if that is the case. I will go look after the workshop and see if I can get you onboarded, and then you can come back and run all this code yourself too. So I'll still walk through it, and hopefully, if you're not onboarded yet, you'll be able to get onboarded. Okay, so I pinged someone, and they're looking at it. So yeah, again, apologize if anyone is hung up on the onboarding thing. Hopefully, some of you are through. Like I'd mentioned, if you have a GitHub account that's new, you might be blocked right now. But yeah, again, someone is looking at it right now. So again, there might be some people stuck. I apologize. I'm going to go through. Let me know if you don't get onboarded sometime after this workshop. Ping me on the Slack and or LinkedIn, and I will look into it for you. But you should be onboarded. If not right now, hopefully shortly after the workshop. Someone's looking into it, so it seems like there might be an issue with some of the accounts coming in. So I'm going to go through this, and I, again, apologize if you can't run this. It's not going to be as fun, I know. But I'm going to go through it, show you everything, and then hopefully you can come back afterwards and rerun it actually in your own notebook here. All right, so for this next part, before we run our whole more complex workflow, which we're going to build down here, you do want to get that Hugging Face token if you can. So again, go to your Hugging Face account. If you haven't made one, you should be able to make one very quickly here. I think it has single sign-on with Google, etc. And then I like to just go to my icon here, go to settings or access tokens. And again, we're going to create a new token. This is going to allow us to write models to Hugging Face Hub. So every time we train a model in our workflow, it's going to save a version of that, and we can always come back and like pull that down anywhere else we need to. So very common to have a workflow like this, whether it's moving to a hub like this or maybe moving a model somewhere else for deployment. You can easily do that kind of inside the Union platform. So here, we're going to give this a name. Again, give this whatever you want. Union example. This really doesn't matter, the name here at all. You don't even really need to remember it for anywhere later in the workshop. And then you just have to click this write access to content. So this is going to allow us to write a model to your Hugging Face account, and then hit create token down at the bottom here. And then you're going to get a token that looks like this. Go ahead and hit copy, go back to the notebook, run this code cell. We're going to create a secret. So this secret is going to be stored in the Union platform, and then you'll be able to access it inside tasks. Kind of hard to see, at least in dark mode, but this is actually a text box right next to that text down there. So click on that, paste in your token, and then hit enter. In my case, it's going to throw an error. Yours, it shouldn't do this unless you already have a token with the same name, which is why it threw an error for me. So I'm going to hit get secret now, and this is going to show all the tokens that exist for me. Yours will probably just say HF token unless you've created other secrets in Union in the past. These are some other ones I use. So these are saying here, these are all the secrets in my Union account. Again, yours is probably just one. If you ever need to delete a token, you could uncomment this and just hit Union delete secret and then pass in that secret name. All right, so we're going to go into our more complex workflow now. Again, this is going to write a file called workflow.py. And what I'm going to do is, because there's a bit of code here, and it takes doesn't take that long to run this. But what I want to do is for you to go ahead and run this code cell down here that says union run remote workflow main. And then we're going to pass in a repo name. What you want to do here is when you could run this code cell without this, and it will just fail later on, but it'll still build an image. And one of the reasons why I want to go ahead and run this now is it can take a few minutes to build a container image with the Python packages that we passed in. And then we're going to go read through the code as this is happening. So if you have your Hugging Face name, go ahead and type it in here. This is my username is SageCodes. And then a repo ID, this can be any name you want. This is going to create a new repo with that name if one doesn't already exist. So I'm going to call mine ML repo. I think you do need dashes in here. Like, I don't think it can be a string with a space. And then we're just going to say our model name is model pickle. You don't have to change this at all. So just update that with your Hugging Face username. and update this with any repo name that you want, and then go ahead and hit run. And as that's running for you, because it can take a few minutes, I'm going to go ahead and read the code above, which is the thing that we're actually running. So for me, it says an image was already found, and I'll show you how it knows this in a second, and it's going to skip building. Otherwise, for you, it'll probably say needs to build an image containing all the Python libraries that we want. So I'm going to scroll all the way up to the top of this code cell, and I'll read through all this code here. It might be a little bit high level. Feel free to ask questions about it. You can pick this apart later if you want to. So we're importing libraries, and we'll just talk about them as we use them. And then here is where we're defining our container image. So I don't know if anyone's used something like Docker before, where you might have be used to writing like some sort of YAML file where you're defining the container image that you want, in this case, our tasks to run. And remember, everything's containerized. So every task basically runs on an image that we define. And today we're just going to use one image for all the tasks, but you could use different images with like less libraries for each one. And then we're defining the Python packages that we want in that container image. And that's all we're really doing today with this thing called image spec, which is built into Flyte. So instead of building Docker containers and pointing to them here, you can actually use image spec, and it'll build those containers for you with the packages you pass in. You can also pass in more details like the version of CUDA you want, more about your environment. You can apt install things. Today, we're just passing in Python packages. But so instead of writing things like Docker files, you can actually just write it straight in your Python now, which is pretty cool. And it'll create the image and host it for you here. And also, just a quick note, all of our code for our workflow is in kind of one big cell today. But you can break this out into modules, so it doesn't have to be like one long code cell. It just kind of makes it easier for the workshop. But you can write this more modularly, as you'd probably actually want to if you're putting this in production. Okay, so first we have a helper function up top too, which is just to convert a chart or charts that we're going to make into HTML, so we can embed them in the task like we saw before with the process data set, where we can embed things like pair plots or any other charts that we want to. We're just converting this to HTML. So these Flyte decks can really have any HTML elements that you want. So you can actually build really complex reports in here, which is very nice if you want to visualize data, how your model's performing, etc. You can embed what we want here in HTML, which is pretty cool. So first, now let's create our first task, which is download the data set. And you'll see that we have this task decorator again, which is saying it's a task of a workflow. But we're passing in stuff. So this is kind of where that declarative infrastructure piece comes in here, where we're just in our task in Python saying what we want this task to run on and any other things that we want to enable. So for me, I'm saying cache is equal to true. So just like in the slides, if you're here for that part, we talked about caching tasks. So when you rerun a whole workflow, you don't have to basically run that task again. A cache state of it's already going to be saved. So in this case, we're going to download the data sets once. Every time we rerun the workflow, it's going to read that from cache, and it doesn't have to download it every single time. But you can adjust a cache number. So if you want to add in a new data, assign it to a different number, or roll back to different cache versions, you can. And then we're passing in container image is equal to image, which is the image we defined above. So again, you could build different images for different tasks. Again, we're just going to be using one image today. And then we're requesting specific resources. For this task, we're requesting 2 CPUs and 2 gigabytes of memories. If you had a much bigger data set, you might need to up the memory here, maybe more of the CPUs if you're doing more processing on it. But this should be sufficient for what we're going to do today. Then we have our Python function, which again, remember, you're really just writing Python, very similar to probably as you would for your pipeline. But you're giving it this task decorator with some specifics around it, and then also strongly typing it saying this task is going to output a data frame. So we're going to load in the iris data set, which we'll look at here in a minute in our process data set function or task, which is where we saw that pair plot. If you're not familiar, the iris data set is kind of a hello world example for machine learning, where it has the petal lengths and widths and a sepal length and width of a flower. And a sepal is kind of like an underbelly petal. And then just based on the data, we're going to predict 3 classes from it. And we're going to create a data frame from that data. And we're going to combine the target, and features together, and we're going to have one data frame that we pass through. Then we're going to have a preprocess the data set. We're going to enable deck, which is, again, that embedded visualization that says we want this button here now, and then we can pass in data and visualize it. We are, again, signing same container image and same resources for this one. But again, you could up it if you're doing more complex workflows. And then we're going to pass out 2 data frames. So one is for the training and testing. So we're going to perform train test split, which is, again, if you're new to machine learning, you're going to use the training data for your model to learn from, or in this case, kind of map to. And then we're going to have a separate holdout data set that our model didn't see. And then we're going to run it as a test to see how well it performs on this data that it didn't explicitly see while training. So we're going to call train test split from scikit-learn, pass in our full data frame. We're going to say the test size is 20%, so 80% of it's going to be used for training. This is a random state where it kind of shuffles up the data. And then we want to stratify it on the target. Stratify means that even though we're shuffling it, we're trying to maintain a certain level of each target for our training data. Otherwise, if you shuffled, it could be like out of the 3 classes that we have today, majority of 2 could be in the training data and 1 is in the test data, and it just doesn't learn patterns from it. And then we're going to create a pair plot from Seaborn, which is that thing we saw embedded. And then we're going to pin that to the Flyte deck with the tab name of metrics, and we're going to convert it to HTML. And then we're also going to return the training dataset and test dataset to use in tasks down the line. Then we're a task of training a model. Here we upped the CPU by 1 and the memory by 1. Not even 100% sure if we needed to. We can actually go look at resources later and potentially tune this down. But again, it's a very lightweight model today that we're working with. But maybe you need more memory if you have a larger data set for it to map here. We have our train model function where we're passing in our training data set data frame. We're saying the number of neighbors that we want. So by default is 3. So remember when we were in the slides, we kind of showed what at a high level how this model works. So if it has a number of 3, it's just going to be looking at the 3 closest neighbors and then making a decision based on that. And then we are initializing the model, which is just the k nearest neighbor classifier with the number of parameters that we pass in. And then we're going to call model.fit, which is kind of where the training happens, where we pass in the training data set and the training target variables. And then we're going to build a task for evaluating. Nothing new here. We're just enabling deck again, so we can embed like our classification or confusion matrix and classification report. And we're going to say evaluate model. We're going to bring in that model that we just trained. We're going to bring in the test data set in this case, and we're going to return a k nearest neighbors classifier from it. We're setting current context, which is kind of setting everything in the container, like where you are. We're going to create the X test and Y test from the test data set, the pandas data frame that we passed in. We're going to create a confusion matrix chart, which if you want to see what that looks like, we can go to evaluate model, open this up. And then this case, our model actually did perfect. But a confusion matrix is useful to see like if a piece of data was mispredicted, which one was it predicted to, and kind of see how that worked. And then we're going to add classification report, which is something in scikit-learn where we can automatically get things like accuracy, precision, F1 score in a report. And then we're going to embed that in there as well. So if you scroll down, you actually see that embedded. And then we have 2 more tasks: is upload model to Hugging Face Hub. The only big difference here is we're bringing in that token that we set above, that secret for Hugging Face. Then we're going to upload model to Hugging Face, which is our function. We're going to take in that model, a repo name, and the model name. This is actually set to, if you're doing this in local development, you can use a .env file and put in your token there as well. If not, it's going to use the Hugging Face secret. And then here we're initializing the Hugging Face API. It's going to create a repo with a repo name that we pass in. We give it the Hugging Face token, so it can do that. And then we're saying it's okay if that repo already exists. We're going to overwrite it. We're going to save the model that we trained with the model name parameter that we passed in, which we just passed in model.pickle when we ran this. And then this is actually the uploading part in the API. We're going to pass in the file object or sorry, the model object or file object is what they call it, but it's the model in this case where it lives in this container right now when we saved it. The name we want it to be in the repo, which we're just going to use the same name. The repo name, which is what we did again when we called run, where I said sagecode/repo name. And we give it a commit message. We're just saying upload model in this case. Repo type we're setting to none, which is going to use the default repo type in Hugging Face, but there's different types that you can use if you want to save like data sets there. And then again, passing our token. And then we have one more task here, which is basically we're going to take the model that we trained and have it hosted here where we can just run it again on any data that we want to pass in. Sometimes, especially if it's a lightweight model like this, I kind of like to have it as an extra step in the pipeline where I can pass in data that I know is like well out of the realms of the training data set or evaluation data set, and I just want to see how the model performs. But also we can rerun this just as a task on the compute and kind of use it as experimentation or actually even as batch processing for a hosted ML model. If you're actually using this in production for like a hosted ML model, I would maybe make another workflow. But again, we'll kind of see this in action here and talk about that in a minute. So our task, nothing new here. And we have model predict, where we're just going to get the predicted class from a model. Again, we'll see what this looks like as we run it. And then we have workflow. So with the workflow decorator is here after all the task ones that we built. And again, this really just is the flow of data and the order of tasks that we want them to run in. So we have our download data set. It gets this data frame. That data frame is used in process data set. It gets train test split. That train test split is used in the train model and evaluate model. And then we use the model file that we generate from there in model predict, etc. And then we have our upload. And if you ran this, if you open up that link, yours should definitely be done running by now. And these should all be green. This is a node view of all those tasks that we built. Again, you can go to this graph view and kind of see actually what the DAG looks like. So we've already seen this so far, but I'll walk through it again. We have our download data set. You can click on each one of these, see what the inputs look like. In this case, we didn't have an input that we passed in, but we had an output, which was a data frame. And by default too, so I didn't mention this before. So Flyte and Union, they serialize and deserialize the data between these tasks to make it more reliable to read in and write out. So you can see this automatically save the data frame as a Parquet file. You didn't have to really think about it. It did it for you. And then that gets passed, in this case, to process data set, where we then have a Flyte deck. And we can go to this metrics tab. You can change the order of these tabs too. I just forgot to do it for this one. You can also change the size of image and everything you want to save here. In this case, this is our pair plot. If you've never used a pair plot before, it's kind of a neat way to see, like plot all the variations of your features together. So in this case, we just have 4 features, the sepal and petal length and width. And you can kind of see how they're broken out per class. So these different color codings here is the class of them. And then this is plotted by sepal length versus sepal width in this case for this top one, etc. And then they just kind of get all plotted out. And it's really cool if you want to see kind of maybe like some clustering going on here. So for example, like we can tell sepal length is pretty different for class 0, this kind of oranger one, or yeah, light tan. I'm not sure what color that is. I mean, see that this one is like always kind of clustered out. So any of these features can probably be pretty useful for identifying that class. But class 1 and 2 are often more kind of mingled with each other. And so using these features would be harder kind of to determine the class that it belongs to. But we can see that the petal length and petal width probably have the most difference between them. And this kind of bell curve plot shows you that too, where there's some overlapping of those features, but a lot less than like these ones. So these are the strongest features probably to help us determine our classes. And in fact, I know because I've done this before with some other things I've worked on, like if you did actually run a SHAP value on this or something, which tells you kind of the feature importance of all these features, these actually are the most important features for like our model that we would build today. That if we just had these 2 features that we trained our model on, it would probably do a pretty good job of still predicting the classes. All right, so if you ran this, again, you ran a whole workflow. I know some people had a problem signing up. Was anyone able to run this that was following along? If you did run this, you built a pipeline. Again, it might seem relatively simple, but it's actually a kind of state-of-the-art machine learning pipeline with maybe a simple use case today but you have things like caching enabled, versioning, flight decks where you can visualize the output of your task. You trained a model, which again, if you didn't do machine learning before, you now trained a machine learning model. You can update your LinkedIn, say machine learning, evaluate a model. We upload it to Hugging Face, and then we have this model prediction task. So I'll go to this Hugging Face one here in a second. But we have this model predict, which if we look at inputs, we saw that we passed it this list of values here, which represents like the sepal, petal length and width. And then we got an output, which was class 0. So it predicted that it belonged to class 0. Now, if we want to, we can actually rerun just this single task and pass it some variables. So we can pass it one list here, or it's a list of lists. So like I mentioned, we can actually use this for batch processing if we wanted to. So you can actually use the task as it is, upload a big list of data, and then get predictions back on it. We'll see how to do this in the Python API here in a minute as well. But first, I'm going to show it in the UI. So let's pass in 4 values. What should they be? Maybe they should be well out of bounds from our training data set just to see what happens. So I'm going to put the first one, 100. What should I put for the other 4 values here? Someone let me know in the chat. Maybe I'll put -70. I'm guessing this doesn't look anything like our training data set. And I guess I'll leave this 0 and see what happens. So I'll hit launch. I put 8,000 for 1, 2. And this is going to kick off the container here in a second and give us a prediction back. So we actually have a model hosted. Like I mentioned, in this case, this would be for batch processing. Like you're okay waiting these like 10 seconds to spin up a container. And already done. Let's click on this. So our input, again, we have these 2 lists now, and we have our output, which is class 0 and class 2. Our data was way out of range, right, from our training data set. So what do we think happened there? If you're familiar with machine learning, you might already know. In this case, the k-nearest neighbors model was looking at the 3 closest neighbors, but it doesn't matter where they are. It could be way out of bounds from our training data. And it's still just looking at the 3 closest and giving us a class predicted back, which is where we're not going into it today. But things like data validation are very important for like models in production, making sure the data kind of meets the distribution that you're expecting. And if it's way out of bounds, maybe alert you so you can go see what's going on there. But we don't have that implemented today. So it's just going to always call this model and give us some sort of prediction back, even if those numbers don't make sense, right? But you should be looking at data schema and seeing like, well, we expect no negative numbers for a flower measurement. Maybe you could have a 0 if you wanted to, but negative, that doesn't make any sense, right? So you can add in things like data validation. We actually have an open source library that's really popular for that too, called Pandera, that you can check out. All right, so I don't see any questions from the chat yet. And I know some people might have gotten stuck for logging in, but I see quite a few people still here. So I'm going to keep going unless people have questions right now. First, I'm going to show we saved that model to the Hugging Face hub. So if you go to your Hugging Face account now and just go to your profile here, you'll have, in my case, I have some test spaces. You might not have those, but you will now have a model here that will be called whatever you passed in the repo. Again, mine is sagecode/ML repo. It says it was updated 21 hours ago, even though I just reran the workflow. The thing is that Hugging Face will automatically kind of check to see if your model file is different at all, not just naming, but like if it is a different type of file or any differences in there. And in our case, the model is exactly the same because I reran this last night or yesterday. And if I go to files and versions, I can now see I have this model.pickle. And if I want to bring that down into a local environment somewhere to use it, I can use Hugging Face Hub again, but I'm going to use this hfhub.download. Again, I'll pass in my username. And if you wanted to, if you weren't able to run the part or put in a Hugging Face account, you could actually type in what I'm typing here and pull my model down if you want to interact with it. So I'm going to say ML repo, and then we're going to look for this model.pickle, pass in our Hugging Face token. Oh, and I think it did it for me because I actually have a secret stored in here. But you might want to take that token that you had before and just put it as a string here. Just make sure you don't commit that to GitHub or anything like that. But you can actually do secret management in Colab. And so you could have HF token paste in your value here as well. Or if you want to do it here, again, just wouldn't commit this code anywhere. You can add in your token directly there as well. Oh, actually, sorry. I think I added that in because if you saved it as a private repo, you need that. But actually, because our repo is just a default public one, you don't need a token to download it. So again, you should be able to pass in like my string here, and you should be able to download it even if you don't have a secret enabled. So now we have our model, and we can look at that model. It actually says it's a k-nearest neighbor classifier with n number of neighbors is equal to 3. And then we can just run model.predict. Again, I passed in some info here, some features, and got classes returned, which is awesome. So we trained a model in a pipeline, saved it somewhere to a hub, and then we're able to pull it back down. So like I've done something like this recently, even with a more complex model of like computer vision, and then pulling it down to a edge device like a Raspberry Pi, and then have it deployed. So very common type of workflow. And then also we saw in the UI here how to kind of rerun a specific task and kind of look at information. We're going to quickly show how to do that in the API as well. So we're going to initialize union remote. And then we're going to look at all the recent executions. So again, that would be like basically for me, I have a whole bunch of executions. You might only have one, but I want to look at all of these this is what it looks like in the UI. I want to do that through the Python API. I'm going to look at the first 100 of them. And for inside of those executions, I'm going to look for one called this workflow.main. That's the name of the workflow that we just ran. So I can see that this is the last one that I just ran right here. So I'm going to do that. And then again, mine's going to be a list of executions. Yours will probably just be a single one. And then what I want to do is get the execution ID of the latest one. So that last one that I just ran here, this is the ID specific to that version. And then I'm going to fetch the whole execution. And I can actually look at this, says like it was under the project of Flyte snacks development, some version information, the outputs here that were saved. And then if I want to just grab all those outputs, I can call execution.outputs, which in this case is a model. And then I'm going to basically take that URI. So this is where the model lives currently inside Union. I'm going to assign that to a variable. And then I'm going to get that task that we reran from the UI, which is that model prediction one. And if you wanted to, you could actually specify specific versions too, but I'm just grabbing the latest one. And now I might predict task, and we can see again some information about it, like where it lives. We can see the variables that it expects as a model type, and then also expects a list to go into. So now we can create an input list or input dictionary for it, where it's the model URI that we got, and then this is a list of values to run a prediction on. And then we can call remote execute and pass in that task, pass in the inputs. And then if we run this, it's going to generate a URL that we can click on. Click to it, and you'll see that it's in progress of running that task. If you wanted to, you can also say wait is equal to true, which will just run that task and then wait for outputs to come back, and you could assign that to a variable. In this case, we want to look at the workflow here. And again, this should just take a few more seconds probably to run. Done. We can see our output here was a class of 0. And if we go down, we can now sync that execution that we already have, which is now going to have the outputs there because it has an output. And then we can grab the outputs from this O0, which is output 0. If you had multiple outputs from a task, it would be like O0, O1, etc. And then we were able to basically do all that from an API. So now actually this model is hosted there, and we can call it and do those batch predictions, which again, actually people use Flyte and Union in this way quite a bit, where you're okay waiting for that container to spin up. We have stuff coming out soon to make that way faster. So you can use Flyte and Union for real-time and your real-time predictions. But for now, you can spin up this container and get prediction outputs from it. And you could tie it all together. Just another example, like instead of each code cell being so separate, what this looks like. And then you can call make prediction on it. And then this has that wait equal to true. So it's going to wait until that container is done running and then give you the prediction returned here. The way we're doing this is we're doing it kind of how Flyte handles data by default, which is like out of a task. You can think of that as a function, and then data gets returned out of the function. You can assign that data to variables and then pass it in just like we did before. But there's actually kind of a cleaner and easier way to do this built into Union with artifacts. So instead of passing data out of functions and assigning it somewhere, you can actually create an artifact inside Union and then reference that artifact between tasks and different workflows. And it makes it way easier to kind of see where your data is. But you also get some compliance aspects where, let me see if I have an artifact in here. In the UI, you can actually get data lineage for that artifact, like what happens to it and what workflows are using it. So this goes back to kind of into the not versioning, kind of versioning, but also like lineage and compliance piece. So talking about things like healthcare and finance, where sometimes they need things required like this, you can do that in Union as well with artifacts and kind of make the whole thing we did here in the API much cleaner, where you can just reference an artifact, pull down a specific version of a model, pull down a specific version of a data set, and then run predictions on them. And that's kind of the end of the workshop that we had structured here. So I'm going to stick around for any questions that people have. But again, we went through a lot, especially if you're new to like building ML pipelines, covered some of the basics, what a bare minimum ML pipeline might look like in production. And then we actually built a pipeline that, again, kind of has like all the new state-of-the-art stuff that you would want in a pipeline in production, where you download a data set, process your data set, train a model, evaluate the model. We even moved the model somewhere else and saw how we could download it. And then we actually used a model hosted in Union as well to do batch prediction as well. So you went through a lot today. Hopefully you had fun and learned something new. For people who did get stuck in the sign-up phase, follow up if you don't get onboarded shortly after the workshop, because I'll go look at that and hopefully get you through as well. And if you have any questions later, so if you want to kind of revisit anything that you saw here, or you have questions later, like if you're watching this on the recording, join us in Slack. And there's even an intro channel there as well if you want to do an introduction to way more people. It'd be great to see you in there. And it's a great place to ask any questions later. And again, we kind of scratched just the surface of everything you can do in the platform here as well. There's a lot more features. And if you want to see more examples with different types of data, different types of data sets, you can check out the other recordings from past workshops. Also check out our blog. We have a lot of cool blogs on there using different libraries and different resources as well. So I think someone mentioned like they were doing Gen AI. There's a lot of good Gen AI stuff in there. Also, like I'd mentioned, I recently just did a workshop on fine-tuning large language models. So a similar type of workflow, but a little bit different for LLMs specifically. And you can check out that recording on the YouTube channel as well. Same with computer vision and object detection. We recently did one on that too, which was really fun. I like computer vision. Like I'd mentioned, that's kind of a big part of my background. So that was really cool to see as well. So I'll stick around for a few more minutes, see if there's any other questions coming in. Otherwise, join our Slack channel and ping us questions there. I still see quite a few people watching or listening. No one's chatting, which is fine if you don't want to. Has anyone built a pipeline similar to this, or even like we talked about, maybe, parts of the slides. Have you built anything and put it in production before? So now that we have our workflow and like our example, you could set up another piece like with the model deployed. Use something like YLabs or Rise for ML monitoring, which is those are platforms where you can send data from production. At a bare minimum, I always recommend looking at the data coming into your model and the predictions coming out of your model. You can learn a lot from that. And then you could look at that, and if like data drifts coming in and varies, and you think the model's not going to be performing well, you could then have like an alert trigger to your pipeline to, if you're collecting data already, like just rerun that workflow. Or you might have someone like annotate data and then kick off this workflow, have a new version of the model, and then put it out into production. So we built a big part of like this train and ship piece today. You would want to implement a monitor piece, but then it makes it really easy to improve it. Maybe also you could even just change the parameters coming into your workflow, where you could easily relaunch it from the UI, pass in a new dataset bucket or something like that, or dataset version, and then retrain your model. And then in this case, it uploads it to the same Hugging Face hub. That model will look different. It'll commit it, and then you'll have that new version of the model in your Hugging Face account, and then you could pull that down wherever your model is deployed. So you can see like I have 17 commits to here. So these are all kind of snapshotted, and I could roll back to any of these commits for my model type and then pull down a specific version if I wanted to, wherever I had it deployed. Cool. If there's no other questions, I'll probably wrap this up, and hopefully I will talk to some of you all later. I will just share my LinkedIn again too if you want to reach out there. But again, I also suggest joining the Slack channel. And I will look into some of the sign up things. So I think I forget if I mentioned it too, but it does say in the slides, serverless is in beta. So sometimes there might be some weird little errors like this. And this is why why it's in beta, and we can catch these. All right. If there's no other questions, I'm going to go ahead and wrap up the stream. Hopefully, again, I'll talk to some of you all later. Thank you, everyone, for coming in. If you have questions, follow up.